sometimes you need to recognize the log rule in your integrals. So if I give you this function right here, and I want you to integrate 3x squared plus 1 divided by x cubed plus 1, you see the denominator has a derivative that is the numerator. So I'm going to do a u substitution. Let u equal x cubed plus x, and then du is 3x squared plus 1 dx. So this integral can be rewritten as du over u, which is the natural log of the absolute value of u plus c. Now, whenever you do an indefinite, you have to substitute back. So this is natural log of the absolute value of x cubed plus x plus c. Now, what about this function? The integral of secant squared x dx over tan x. If I let u equal tangent of x, then du is secant squared x dx. So the integral becomes the integral of du over u, which is the natural log of the absolute value of u plus c. So this is the natural log of the absolute value of tangent plus c. Now, what if I have this function right here, the integral of x plus 1 dx divided by x squared plus 2? If I let u equal x squared plus 2x, du is 2x plus 2 dx, which I'm going to rewrite this as 2x plus 1 dx. Because I have x plus 1 dx here, I'm going to solve it. X plus 1 quantity dx is equal to du over 2. Now plugging this back in, x plus 2 dx is equal to du divided by 2 times 1 over x squared plus 2x, which is u. So this is 1/2 the integral of du over u, which is 1/2 the natural log of the absolute value of u plus c, which is 1/2 the natural log of the absolute value of x squared plus 2x, oops, ran out of space here, plus c. All right, let's do another one. Let me let, in this case, u equal 3x plus 2. Then du is 3 dx. So dx is du over 3. Plugging this all in, this becomes the integral. Dx is du. Now, do you mind if I drag this 3 out here? You can do that. So this is 1/3 the natural log of the absolute value of u plus c. And remember, you have to plug back in. So this is 1/3 the natural log of the absolute value of 3x plus 2 plus c. All right, now let's look at this one. This one is a little bit more complicated than the ones we've been doing because the power of the numerator and the denominator are the exact same. So the first thing I'm going to do is long division to see if I can rewrite this. So if I take x squared plus 1 and I divide it into x squared plus x plus 1, x squared goes into x squared one time. 1 times x squared is x squared. 1 times 1 is 1. And there's a plus there. Now I'm going to subtract these two. That's 0, so I'm left with x. So this becomes plus x divided by x squared plus 1. So I can rewrite the integral as 1 plus x over x squared plus 1 quantity dx. Now, this first one is, when I do this integration, let me break them up. This is the integral of dx plus the integral of x dx divided by x squared plus 1. Now this first integral is just x plus. Now here, I'm going to come up here in red, and at this point in time you should be able to do this. If u is x squared plus 1, then du is 2x dx. So I need a 2 and a 1/2 because I can't just change the integrand. But multiply by 2 and a 1/2 is fine. So I have 2x dx, so this right here is du over u. So this becomes 1/2 the natural log of x squared plus 1 plus c. Now you see I don't have any absolute value signs here because x squared plus 1 is always positive. Now finally, you may need to change variables when you're using log rules. So suppose, let me let u in this case, because I don't have a clear u to u situation, let me let u equal x plus 1. Then du is equal to dx, but let me solve this for x. X is u minus 1. Now let me plug all of this back into my integrand. I will have, I'm going to factor this 2 out. X is u minus 1. Dx is du divided by x plus 1 squared, so this is u squared. So now I have 2 times the integral of du over u minus the integral of du over u squared. And of course, I need to carry my brackets. All right, so this becomes 2 times the natural log of the absolute value of u minus, now this is u squared, so it's u to the minus 1 divided by minus 1, and the whole thing plus c. I always put that plus c on the outside. So let me substitute back in. This is 2 times the natural log of the absolute value of x plus 1. Now this is going to be plus, sorry about that, plus 1 over x plus 1. Now I need to carry this 2, so this is 2 plus c. Erase a little more than I planned to. Let me rewrite that. This is 2 natural log of the absolute value of x plus 2 over x plus 1 plus c.